So today we're doing Module 2.2, graphing logarithmic functions and transformations on those log functions. So when you're done with this, you'll be able to graph a logarithmic function and understand the transforms and the shifts. Any function that we have, be it whether a linear function, quadratic functions, any of those, we've been able to shift from a, what we call a mother graph, a parent graph, and been able to shift it. Let's think about linear equations. There's our mother graph for excuse me, for a linear equation. We can shift that down, right? We can flip it backwards. We can shift it and move it around all the ways that we want to. Logarithmic functions are no different. So because logarithmic functions are the inverse of exponential functions, it's easiest to graph one of those first. So for all of these, we're just going to use a real simple t-chart using -1, 0, and 1 as our values. It's going to be very simple for you to do. So let's graph the following. We're going to use base of 2 to start with. So y equals 2 to the x power. So the x values are the independent ones that we can choose. So we're going to use -1, 0, and 1. So 2 to the negative first power is 1 over 2. Remember, it's like that's 2 to the first power. It's a reciprocal, so it's 1 over 2 to the first. 2 to the 0 power, we know anything to the 0 power is 1, and 2 to the first equals 2. So if we graph that, we have -1, 1/2, 0, 1, and 1, 2. Remember, we were discussing in class on Monday and Tuesday that you cannot get an answer that's a negative. Okay, that's not going to happen. It's going to cruise right along here to the x-axis, but it's never going to go below that because we cannot find any number that we could put in for x that will give us a negative result. We would get fractions that are smaller and smaller and smaller. As small as the x value is getting, the more negative it gets. That fraction will get smaller, but it won't ever be 0. So now if we're going to graph the inverse of that function, what happened here in our functions? The x and the y simply swapped places. And that's how we know we have to find an inverse function. So we already know that from Module 1. So the nice thing is that we can now take our values for x and y, and we can flip-flop those as well. You probably remember doing that in Module 1 as well. So I'm just going to take whatever was an x coordinate is now going to be a y coordinate. Whatever was a y coordinate is now going to be an x coordinate. And if you're not sure about that, do the same thing again. 2 to the negative first gives me 1/2. 2 to the 0 gives me 1. And 2 to the first gives me 2. Now we're going to graph those points. We're going to go over 1/2, down -1, 1, 0, and 2, 1. So now also inverse, instead of kind of coming along the x-axis like it did with our exponential function, it's going to come along the y-axis. Okay? So here's a good question. What is another way you can write the function of the second graph? So now that we know logarithms, we know that we are always solving for that exponent. So it'd be y equals the log of 2 as our base, and x is our answer. So we actually just did graph the log function for base of 2. Okay? So now let's do another one. Let's graph the log base 4, so log of 4x. Okay? Same thing again. Do a quick, simple t-chart. You don't need to have more points than this. This is sufficient information for us to graph. So, I'm sorry. We're doing log of 4 to the x. So the easiest way to do that is switch this around to exponential form. It's actually much easier to graph in exponential form because it's a little easier to look at. So it'd be 4 to the y equals x. So this would have been the exponential form. We're going to go the inverse of that, which is we're going to put all of our inputs at y. So -1, 0, 1. Okay? So now, 4 to the negative first gives you 1/4. 4 to the 0 gives you 1. And 4 to the first gives you 4. So instead, you're just flip-flopping. This would have been if we had 4 to the x equals y. But of course, our log is the inverse of that, okay, which is 4 to the y equals x. So if we have 1/4 -1, which is going to be about there, 1, 0, and 4, 1. So there's our graph. Okay, just like that. Okay, let's see what happens when we do log of 1/2 x, and see maybe if it compares to one of the first two that we did. So let's write that as an exponent. We know that f of x is the same as y. So that means 1/2 to the y equals x. So again, I'm going to use my y's as my input this time because it's the inverse. My x is now my output, in theory, if you want to look at it as a graphing method. So -1, 0, and 1. 1/2 to the -1 means I need to raise that to the first power, which would be 1/2, and then I need to flip it over and use a reciprocal because that negative tells me a reciprocal. So that would be 2. 1/2 to the 0 power would be 1, and 1/2 to the first power would be 1/2. So that's 2, -1, 1, 0, and 1/2, 1. So really what it did from our our log 2x, just flip that over. This is a number less than 1, so it means it's decreasing, right? Remember, decay is less than 1, growth is more than 1. So this is growing, 2 is more than 1, this is decaying, 1/2 is less than 1. Okay, good. Let's go to the next page. When we're talking about logs and shifts, there's a great video I came across on YouTube. I strongly suggest that you go see this. It's quick, about 5 minutes, but she explains very well how things shift. I'm going to try and do that for you too, but it's a great explanation. It's worth 5 minutes of your viewing pleasure to go see that. Okay, so let's start with what's occurring now is what happens if we take that basic equation that we started with, which was y equals log 2x, which was this right here. Okay, now we're going to see when I adjust that a little bit what happens. Okay, and you're going to see differences based on whether that number changes within the parentheses or outside the parentheses. So this is within the parentheses. So let's do our log 2x first. So our log 2x, okay, which is what we had from the first page, -1, 0, 1. And we had 2 to the negative first is 1/2, 2 to the 0 is 1, 2 to the first is 2. So what's happening here is when it's within the parentheses, it's going to decrease each of my x values by 1. Okay, it tells me what do I have to do to make this be 0. If I had log 2x, right, I need it to be a log 2x. It's subtracting here. I'm going to have to counteract that with the opposite to make this back to 0. Okay, so it's going to be a horizontal shift to the right by 1. Okay, and you'll see in a minute what happens here. So my y values aren't changing, so I'm just going to leave them alone. They're fine. But all of my x values are going to decrease by 1. I'm sorry, they're going to increase by 1. So what you're asking yourself is, what do I have to do to get this value in here to equal 0? Okay? What has to happen to get back to x? So I've got to counteract that. So I have to add 1. Okay? So I'm going to add 1 to each of my x values here. So that would be 3/2, 2, and 3. And if I graph that, I would get 3/2, -1, 2, 0, and 3, 1. So all it did was, now it shifted my whole curve by 1. And what actually happens is your asymptote, that imaginary line that we don't go past, is now at x equals 1. So the asymptote is at x equals 1. So let me be clear, because that was a little confusing at the beginning. You always want to know when it's within the parentheses, what do I have to do to get this to go back to x, because that was my basic graph that we started with, was just log of 2x, okay? The equation is making it go -1, which means we have to push it back the other direction by 1 to get back to x. We have to do the opposite. So it's a horizontal shift, the opposite of what you see. If you guys remember graphing absolute value, that was the same thing. If it was within the parentheses with the x, it was a shift horizontally of the opposite of what you see. Okay, so now let's look at log 2, x minus 1 in parentheses minus 3, and see what happens there. So now we can use this. This is our graph. These are our points for log 2, x minus 1. So we can use this as our starting point now and just adjust them how we need to. So now what's changing is we are taking our answer there and decreasing it by 3. So the numbers that are going to change in this case are going to be our y. So this is going to be a vertical shift down 3. So our x values are not going to change. They're fine, 2 and 3. But all of our y values are going to shift down by 3 because it's not within the parentheses. It's our overall answer, right? Because this is y equals that amount. It's this answer that we have subtracting 3. So -4, -3, -2. So let's graph that. We have 3 halves and 1, 2, 3, 4, 2, -3, and 3, -2. So what that did now, we still have our same asymptote at 1, because that was established by this, okay? But now our curve, not only has it moved over, but it's shifted down. Use one of your points as a guide. It went from 2, 0 to 2, -3, shifted down by 3, okay? So our overall rule is if you have log the base x minus a plus c, okay? That's going to result in a horizontal shift, of the opposite of a and a vertical shift by c, okay? So within the parentheses, it's going to do the opposite horizontally. If it's outside the parentheses, that's going to affect your y values by whatever that number that is. So if that had been a 5, it would have shifted our entire graph up 5. If this -3 had been -1, it would have shifted it down only to 1. Okay? All right, so before you graph these, it's probably good to think about what is my graph going to do. Okay? So we can start with our log 4x, because we already had that from before, from the last page. So we had, let's check, we had, for our values, we had 1/4 -1, 1, 0, and 4, 1. So I'm going to use those as my base. 1/4 -1, 1, and 4, okay? But now, what is happening to each of those values? Okay, so you should be telling yourself that's a horizontal shift, and this time it's going to be -3, so it's going to shift to the left 3. So I'm going to decrease each of my x values by 3. Okay, so my y values are not changing. They're fine. They're going to stay just where they are. Each of my x values are going to decrease by 3. So let's do these first. These are the easiest. 1 minus 3 is -2. 4 minus 3 is 1. 1/4. 3 is the same thing as 12/4. And we're going to subtract a 4, so this would be 11/4. Okay? So when you graph that, 11/4 is almost 3. So it's right about here. 3, -1. I'm sorry, this one is not right. we're just subtracting by 3. So this should be a -3 and a -2. There we go. Okay. So -3, 0, and, oh, let's start that over. I am so sorry. Okay. This should be a -11/4. That would make more sense, wouldn't it? Because this was -12/4 plus 1/4, or 1/4 minus 12/4. Sorry about that. I was thinking my graph is off. There should be a negative in there somewhere. So please ignore these two spots. It should be -11/4, which is almost 3, down 1, right there. -3, 0, and -2, 1. Not that point there. So your graph should be going something like this. That was a rough problem for me. I apologize for that. We'll do better next time. Okay? So my whole graph, if we look at our original graph of log x, this is our original graph. Let's just go ahead and graph it. We have 1/4 and -1, 1, 0, and 4, 1. So my whole graph, right, same curve, it just shifted to the left by 3. Okay. Okay, here's what we're doing. I completely confused you on this. So I'm going to flip this over on the back, and we're going to start from scratch. Okay? I could edit my video. Don't really know how. Not really going to take the time to figure it out. So log of 4 to the x plus 3. We know that our whole graph has to shift to the left by 3. Okay? Horizontal shift of -3. Okay. So our log of 4x graph was, we had inputs of -1, 0, 1. We had outputs of 1/4, 1, and 4. So let's graph that first graph, which would be 1/4 -1 would be about here, 1, 0, and 4, 1. So there is our original graph using the y-axis as our asymptote. We're not going past it. Okay? So this is the graph of log 4x. Then, if we're going to do log of 4 to the x, we'll have, 4 to the x plus 3, we will have xy. We're decreasing each of our x values by 3, but we're not doing anything to our y values. So 4 minus 3 is 1, 1 minus 3 is -2, and 1/4 minus 3, 1/4 minus 3 would be the same as 1/4 minus 12/4, which would give us -11/4. Much better this time. Okay, so we have -11/4, so we're going to scooch over here, -1, -2, 0, and 1, 1. So there's our new graph. Looks just like the other graph. Okay, so we shifted it to the left 3. This is what okay, in between these spaces, this space is 1, 0, right, and this space is -2, 0. I know there's a shift of 3. 1, 2, 3 spots. Much better. Okay. Now moving on. So now let's ask ourselves, we already know that we're going to have a horizontal shift to the left, right? Horizontal shift to the left of 3. And now because I see that +2 and it's outside the parentheses, it's also going to move my graph up by 2. So you're going to take all of your y coordinates now and those are what are going to shift. So our log 4 to the x plus 3 coordinates were, nothing in our y's had shifted, right? But these were negative 11/4, negative 2, and 1. Okay, now I'm going to take all of that and shift it up by 2. So I'm going to add 2 to each of my y coordinates. So my x coordinates are not changing, but all of these are going up by 2. So negative 1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3. Okay, so we will have negative 3/4, which is about there, 1, negative 2, 2, and 1, 3. We can even graph that on our other side so you can see all three of them together. So this would be log 4 x plus 3 plus 2, taking all of these y coordinates and increasing them by 2. So 1, 2, and 3. Let's do that in a different color. Okay, what have we got? We'll do negative 11/4, 1, negative 2, 2, and 1, 3. So now all it did was take our curve and shift it up. So this is y equals log 4 x plus 3 plus 2. Okay? I took our basic graph and just shifted it. First we shifted it to left 3, then we shifted it up 2. To the left 3 and up 2. Okay? All right, last thing in this section that you need to review on is raising a power to a power. This should definitely be a review. When you raise a power to a power, when you have the base and you're raising it to an exponent, and that again is raised to another exponent, it is the same as the base, and you multiply those exponents together. Okay? If you have base to one power times the same base to another power, then we are adding those exponents together. I learned this a long time ago in algebra. You've been using it a lot. You should be fine with this, but that's just a quick review. So go ahead and try these on your own, and all of your answers should only have positive exponents. So if you end up with one that has a negative exponent, you would need to change that to reflect that you understand that you need positive exponents. So hit pause on your video and then come back and check your work. Okay, so now let's check 11 through 22. So 2 times 3 is 6, so this should be 4 to the 6th. I'm not requiring you to multiply these out right now. You know how to do it on your calculator for future reference, but you don't have to do it right now. Y to the 5th to the 4th, I need to multiply those together, so that gives me y to the 20th. C to the 9th, there should be a parentheses around there. If some of you did 9 minus 11, that's fine. It should be c to the 9th to the negative 11th power. That would give me c to the negative 99th. I know the negative exponent means reciprocal, so that means that I put it to the bottom and make that exponent positive. Remember that when you're raising things within a parentheses to a power, everything gets raised to its power on its own. So 3 times 5 is 15. If there's no exponent, it's understood to be a 1. 1 times 5 is 5. Number 15, negative 8 times 4 would be negative 32. Again, I can only have positive exponents. So I would have 1 over b to the 32nd. Negative 5 times negative 6 is positive 30. And I would leave it just like that. Those two negatives eliminated each other. They canceled each other out. Turned it to a positive. Okay. Here we've got two steps. We have b to the 7th times b to the 9th to the 3rd. Using PEMDAS, of course, GEMDAS, you've got to do this part first. We raise exponents first. So you would have b to the 7th times b to the 27th. Now I need to add those exponents together. So I get b to the 34th. Same thing's going to happen on number 18. I've got to combine these first. So I have x to the negative 8th times x to the 18th. Negative 8 plus 18 would be x to the 10th. Four times negative 9 is negative 36 times y to the 36. I need to add those together, so I get y to the 0, which equals what? Anything to the 0 power equals 1. Okay? Here we would have negative 3 squared. I have to raise everything to that power, so negative 3 squared and a times to the 7 times 2. So negative 3 squared is 9. 7 times 2 is 14. Okay. Almost done. Negative 2 times 3 is negative 6. I can only write that with positive exponents, so I need to move that to the denominator and make it a positive exponent. And last but not least, I'm sure you'll all be happy to have this module done, considering my speaking within it has been kind of interesting. So, raise everything to the 2nd power. So you have 4 squared, x to the 8th, and y to the 10th, and you should simplify that to 16 x to the 8th, y to the 10th. Okay, that is it for Module 2.2. Hopefully you will look forward to Module 2.3. Thank you.